This is the second video in the series. It is going to review an Algebra 1 skill, dividing by monomials. So here we have a polynomial, 6x to the fourth y cubed plus 12x cubed y squared minus 18x squared y. And we want to divide that by the monomial 3xy. So the way that we do that is we rewrite the problem, or at least in our head we rewrite the problem. You don't necessarily have to show this work step unless the directions say to do so, where each term in the polynomial is written as being divided by the monomial divisor. So we would rewrite each term, there are three of them, divided by 3xy, and then we're going to go in and carry out that division. So 6 divided by 3 is 2, and then for each variable we're going to subtract the exponents, top minus bottom. So for x, we have x to the fourth on top, x to the first on the bottom. 4 minus 1 is x to the third. Y, we have a 3 on top, a 1 on the bottom. 3 minus 1 is y squared. So this first term would reduce to 2x cubed y squared. Divide the coefficients. 12 divided by 3 is 4. Then we subtract the exponents. X to the third over x to the first is 3 minus 1, or x squared. Y to the second over y to the first is 2 minus 1, or y to the first. So 12x cubed y squared divided by 3xy is 4x squared y. Minus 18 divided by 3 is 6. We have x to the second over x to the first, which is x. We have y to the first over y to the first, which would be y to the 0, but we don't have to write that because that is equal to 1. So our quotient would be 2x cubed y squared plus 4x squared y minus 6x. Let's look at a couple more examples. Now in the process here, we're going to have a couple of different notations that might come up. So number 1 has the second type of notation where we show the polynomial being divided by the monomial using a division symbol. Doesn't change anything. We still do it exactly the same way. So we rewrite each monomial term over our divisor. 16 CDF squared divided by 4 CDF plus 4 CDF over 4 CDF. And it's this last term that is the reason why we're looking at this example, because a lot of students will fail to realize that when we divide these two things, there is still a number there. It doesn't just drop out. So anyway, let's go through them in order. 20 divided by 4 is 5. C to the fourth over c to the first would be 4 minus 1, or c to the third. D to the second over d to the first would be d to the 2 minus 1, or d to the first. F to the first over f to the first would cancel. Minus 16 divided by 4 is 4. C to the first over c to the first would cancel. D to the first over d to the first would cancel. F to the second over f to the first would be an f. So we would have 4f. And then plus 4 divided by 4 is 1. C cancels, D cancels, F cancels. So there should still be a plus 1 on the end. And a lot of students don't realize that and leave that term off the answer. So our answer would be 5c cubed d minus 4f plus 1. Number 2, this notation always confuses kids, and I'm not really sure why. When we have a negative exponent, that means that that whole term that's being raised to the negative exponent is going to move to the bottom of the fraction. In other words, this could be written as 18x squared y plus 27x cubed y squared z over 3xy. That's what that notation is saying. That negative exponent means write it as a fraction. Which means we're looking at the same problem we've been doing. We have each of those two terms divided by 3xy. So 18x squared y over 3xy plus 27x cubed y squared z over 3xy. And then we're going to divide just like we've been doing. 18 divided by 3 is 6. X squared over x to the first would be x. Y to the first over y to the first, y would cancel. Plus 27 divided by 3 is 9. X to the third over x to the first would be x squared. Y to the second over y to the first would be y. And z, well, there's no z on the bottom, so we're not subtracting anything. We're just keeping it as part of the answer. Z would still be there. So our answer should be 6x plus 9x squared yz. That might be it. That is it for the second video.